Today I'll be covering the concepts on vectors at JC level. So for vectors, basically you have a vector A equals to A1, A2, A3. Modulus of A will be equals to the magnitude of a vector will be A1 square plus A2 square plus what? A3 square. So that's concept number one. Concept number two, a unit vector is equals to a vector A divided by the magnitude. Concept number three, a vector parallel to another vector imply that A will be equals to K times of what? B. So that's concept number three. Next, concept four is if I have the ratio theorem AB and basically C divides AB in the ratio lambda mu. So OC, the vector OC will be equal to lambda OB at mu times of OA divided by lambda plus mu. So this will be your ratio theorem, which goes down to the fifth point, your midpoint theorem. The midpoint theorem, your AB, your M divides AB in the ratio 1 unit, 1 unit, midpoint. So with that, your OM, vector OM, will be equals to 1 unit of OB at 1 unit of OA divided by 2. Okay? So this is the fifth point, which is the midpoint theorem. Okay? Moving on to the sixth point. The sixth point is a parallelogram. So for vector, the parallelogram A, B, C, D are parallelogram. So your vector AB will then be equal to vector DC, and your vector AD, for example, AD will be equals to vector BC. Taking note of that is your displacement vector AB can be written as OB minus OA. Of course, we also learn vectors addition. The vector A to B add B to C will be equal to the vector AC. So learning point over here, the vector AC will be A to B add B to C, which is the eighth point. So at this point, I pause. I will be moving on to cross and dot product next. So learning point next will be your scalar product. So for scalar product, I will have A dot B will be equals to A1, A2, A3 dot B1, B2, B3, which is equals to A1, B1 at A2, B2 at A3, B3. Concept A dot B, scalar product will be modulus A modulus B cosine theta. This is the angle between what? Vector A and B. So my cos theta will be equals to A dot B divided by magnitude of A, magnitude of B. Moving on. Your A dot B will be equal to 0 if A is perpendicular to B. So this is the concept for your scalar product. With that, I will move on to the cross product. Can cross product next. Now for cross product, I will have A1, A2, A3 cross B1, B2, B3. To get your I component for your cross product, first of all, I cover the top. It will be A2B3 minus A3B2. All right, Ken? So it will be what? A2B3 minus A3B2. Next, for the J component, Ken, I will cover the middle, Ken, then it will be A1B3 minus A3B1. So but you need to put a minus here. Take note, you'll be A1B3 minus A3B1. So bear in mind, there should be a negative here. There should be a negative here. And last but not least, to get the K component, I will cover the last part over here. Then it will be A1B2 minus A2B1. So you'll be A1B2 minus A2B1. So your cross product. Now, basically, cross product will be A cross B will be equals to modulus A modulus B sine theta. And what is cross product? Vector A here, vector B here. So cross product is to get a vector that is perpendicular to A and B. So you can see my A cross B will be perpendicular to A. My A cross B will also be perpendicular to B. So when you cross both vectors, you are getting a vector that's perpendicular to A and B. So introducing our cross product. And finally, there is also, take note that there is one application for the cross product, and that is if I have an area A, B, and C. So area here, to get area of A, B, C, you find the magnitude of AB cross what? AC. So go ahead, step number 1, find the cross, proceed by finding the magnitude to get the area ABC. So this is one of the application for cross product. Ken? And there will be still some other miscellaneous concepts, like for example, if I have a vector A and I need to project onto the vector B, I need to length of projection. I want to project vector A onto B. So length of projection of vector A onto B, the concept will be A dot B cap. And last but not least, concepts like x-axis. When you're given the x-axis, you noted that the vector, you can use 1, 0, 0 to represent x-axis. Y-axis, you can use 0, 1, 0 to represent. And z-axis, you can always use the vector 0, 0, 1 to represent the z-axis. So today I cover vectors 1, and next lesson I'll move on to vectors 2 on lines and also on abstract vectors. Thank you very much. Please be doing the tutorial that is already sent to you. Thank you.